Okay, let's see how the sampling will do when we have some special cases. Okay. So first we're going to discuss what if we're sampling from a normal distribution. When we say we're sampling from a normal distribution, it means the population distribution is normal distribution. Is normal distribution. Okay. Sampling from basically everything I perform will be your population distribution, meaning the distribution of each data point. So meaning xi, each data point in your sample will follow this normal distribution, defined by your population mean mu and your population variance sigma squared naturally. So if this is the case, what happens is the following. From the central limit theorem and from the discussion in probability theory, x bar, your simple mean, a random variable statistic, also follows a normal distribution as we discussed with the same mean mu, but with a variance sigma squared divided by n. Okay. So if you compare the two, what do you see? You're comparing the second line and the one above. Well, the only difference is right here, because both of them have the same mean. If you look at mu, they have both the same mean. This is the unbiased estimation for x bar. Now, the variance is different, and since n is the sample size, the number of items definitely going to be larger than 1, that means the variance for x bar is definitely going to be smaller than the variance of each data point. It means when you are taking the average, you are implicitly reducing the variability contained in the data you're going to report. If you only do it once, report this number to your boss or instructor, well, it may contain some variability. If you're lucky, good. If you're unlucky, well, maybe the number is far off. But after you take the average of many numbers, you're basically filtering out those variability because of this n sample size in your denominator. Okay? So that's the reason, the main reason why we're doing n. And quantitatively, this is how much reduction in the variance, in the variability we can achieve. Easy, right? Now, what about s squared? It's also a random variable. It also has a distribution, but the question is, what is the distribution? Okay. Now the distribution of s squared is not a standard one, but we introduce a new random variable, we call it y. So we introduce a new random variable, we call it y equal to n minus 1 s squared divided by sigma squared. This is a special random variable, but fortunately people have carried out a lot of studies and they found out, well, if this is how you define your random variable, that's why. Then y follows a distribution called the chi-square distribution. And chi-square distribution is only defined by one parameter called the degree of freedom, and that is n minus 1. So let's see, I'm going to do this. This is a new distribution. We haven't discussed it because from the probability perspective, it's not really important. So this guy is called the chi-square distribution. Now, when we pronounce it, make sure you pronounce it as chi-square, not chi-square. So it should pronounce as chi-square distribution, not chi-square. Okay. Now, as I mentioned, the chi-square distribution has a parameter, n minus 1 here, and is the number of data points minus 1 is your sample size minus 1. This guy is called degree of freedom. Okay. It's the only parameter for chi-square distribution. It's like for normal distribution, if you want to specify a normal distribution, you want two parameters. You need to know the mean, you need to know the variance. And when we talk about chi-square distribution, you need to know n minus 1, and that's it. It will define the shape, the curve of the distribution. Okay. So this is the chi-square distribution. And now we have the distribution that will help us calculate or quantify the behavior of our sample variance S squared. Okay. So these two are sort of important. Now, there is another distribution we usually use related to sampling from a distribution. Okay. That one is called T distribution. Okay. And T distribution is defined like this. Okay. It's defined as x bar minus mu divided by s over square root of n. This is the T distribution. Okay? So this guy follows a T distribution. Again, with something called the degree of freedom. And that degree of freedom is n minus 1 again. So let's do something similar as before. So this is going to be a new distribution, also defined by a parameter. So we're looking at a T distribution. And this is again the degree of freedom. T distribution sometimes is also called student distribution. It's because the mathematician who derived T distribution used the name student when he published the result. At the time, he was working in the beer company, the Guinness beer company in Ireland, and the company, of course, didn't allow their employees to publish the results related to their manufacturing process, so you have to use a fake name, and this mathematician used the name student when he published this result. So that's how the name comes to play. So this is what we call the T distribution. All right. Now, the last distribution that is sort of related to the talk is what we call the F distribution. Now, F distribution is a little different from what we have above. It's when we are sampling from not one, but two normal distributions. So we have sample 1 from normal distribution 1. And we have another sample number 2 from another normal distribution number 2. Okay. And let's assume for normal distribution number 1 we have mu1 sigma 1 square. And number 2, we have n, and we have mu 2 sigma 2 square. So they may have different mean, they may have different variance. Well, it's normal. As I mentioned, maybe you're comparing two players, two designs, two group of people, right? Two countries. So naturally, you can draw, two samples, one sample from each distribution or from each population. And let's say if you want to do comparison, but we're going to compare the sample variance from the first sample over the actual variance of that population divided by the sample variance of the second over the sample of the population variance of the second population. Since S1 is a random variable, S2 is a random variable, the division of these two is also a random variable. And again, this is a very special random variable because of the populations, both of them are drawn. And again, mathematicians did a lot of derivation, and they found out, well, this is actually a standard distribution they can take advantage of, and they call it F distribution. And F distribution is defined now by 1, but 2 parameters again. Okay, so it'll be n1 minus 1 and n2 minus 1. So let's use the first, second, and third. So three things. So this means we're looking at F distribution. Now, n1 is the size of sample 1. What is the number of individuals in sample 1? Number of data points in sample 1. And 2 is the number of data points in the second sample. But it's again a very special distribution. So quickly go back. Now we're talking about sampling from a normal distribution, what we can expect, and we find out, well, if that's the case, if we're drawing distributions from a sample from a population of normal distribution, then we can quickly figure out the distribution for x bar, and we can figure out what is the distribution for the sample standard deviation with the aid of this intermediate variable y, which will be a chi-square distribution. And also, this special thing, t, will follow distribution, a t distribution or student distribution with degree of freedom n minus 1. And finally, if we're drawing samples from two normal distributed populations, then we have the S distribution that can help us sort of compare or to contrast the variance from the two samples and populations. Now, we have these distributions, and if you read the textbook, the discussion is from section 4.1.1, I believe. It gives all the derivations and also the expression of the probability density function. The probability density function are really not important. Okay. You're never gonna use those distributions unless you really want to do some hardcore statistics, which I don't think that's the purpose of this course. Now, what is important is you need to know the sampling distributions that we'll be using. And of course, in the following discussions, we'll be reinforcing our discussion. Okay. We'll be looking at, well, when we want to know something about x bar, well, we'll turn to normal distribution. When we want to know something about the standard deviation of the sample variance or the variance, we'll look at chi-square distribution. When we're dealing with something like this, we'll look at a student distribution, and we're comparing the variances, we'll be looking at the F distribution. Okay. Now, as far as calculation is concerned, all the distributions the calculus related to all these distributions can be done using computers, either Excel or Minitab. We'll do the actual examples when we're in the following sections. Um, and they also can be done by hand. The back of the textbook includes a number of appendix tables. We have seen the Z table, right? That's you usually use when you're trying to do some calculations related to normal distribution. It also has T table and the chi-square table, which can be used to help you calculate something related to the chi-square distribution, T distribution, and the F table, which will be related to the F distribution. So we'll all come to that when we're there. But this is what we would like you to know as far as the sampling from a normal distribution is concerned. What are the sampling distributions? What are the probability distributions related to these statistics? Now, final comment on this subsection. You may wonder, well, why do we call these guys degree of freedom? We have degree of freedom here, right? We have degree of freedom here. We have degree of freedom here as well. Just didn't call them there. The reason we're calling them degree of freedom, literally it means how much freedom you have in the calculation. Okay. And the reason it's n minus 1 is also related to the way we define our sample variance right here. Okay. Now, why is n minus 1 but not n? It's because when you have your x bar, when you know the average, then that means you only need to know n minus 1 individual data points to find out the last one. That's your degree of freedom. You cannot, when x bar is fixed or x squared is fixed, you can only play around n minus 1 data points, change some of them because the last one will be determined automatically. You cannot freely change all n data points because you are constrained by the sample mean sample variance. This is how why we call it degree of freedom. You can only play these n minus 1 freely, the other one will be automatically determined. Okay, so this is what happened when we're sampling from a normal distribution. Okay. In the next video, we'll discuss what happens if we're sampling from a Bernoulli distribution.